All right, we're going to start 2011 question number 5 from the AB free response questions. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW over dt equals 1 over 25 times the quantity of W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. So that gives us a bunch of information. One of the big things it gives us is an initial condition. W of 0 was 1,400 tons. Okay. All right, that's because T, even though it's 2010, T is measured from 2010, so that would be T equals 0. All right, it says part A. Okay. Use the tangent line of W at T equals 0 to approximate the amount of solid waste at the landfill contained at the end of first 3 months, which is at T equals 1/4. All right, so we need to make a tangent line first. Tangent line requires a point and a slope. All right, well, they're dealing with at T equals 0. Well, hey, we have the point. The point is 0, 1,400. We just got to figure out the slope. Now, they gave us a differential equation. Remember, a differential equation is nothing more than a derivative, which is how we find the slope. So dW over dt is equal to 1 over 25 W minus 300. And if we just go ahead and put W in, 1,400, we're going to evaluate this for T equals 0. 1 over 25 times 1,400 minus 300. This gives us 1,100 over 25. Now you can leave that totally like that. There's nothing wrong with that. If you don't want to figure it out, that's okay. It's free response. You don't have to simplify anything. All right. For the sake of writing, I'm just going to tell you that it's 44. Okay. So our tangent line, and even though we're used to doing y's and x's, you got to remember that this is dealing with W and T. So W is the y value and T is the x value. So I'm going to make this W minus 1,400 equals our slope 44 times T minus 0. Now that's just our tangent line. They want us to use this to approximate the amount of waste at T equals 1/4. So that means I'm going to plug in 1/4 for T. So W minus 1,400 equals 44 times 1/4 minus 0. Now I do want to make sure I do one extra thing. I don't want to leave this minus 1,400 over here. I want to actually answer the question. I want to know how much waste is there. So I'm going to add that to the other side. And this is just 44 times 1/4 plus 1,400. And this would be in tons. Make sure we use that units. Okay, and we can leave it like that, or you could go ahead and simplify. And that would wrap up part A. Part B, it says find the second derivative in terms of W. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the solid waste in the landfill at T equals 1/4. So let's find that second derivative. Okay, we're going to take that differential equation that they gave us. And the big thing you got to remember, to do the second derivative, you got to remember what your variables are. This is in respect to T here. So when you do the derivative, we're actually going to use implicit differentiation. Because, and it may be easier for you to distribute this to C. If you rewrite it as 1 over 25 W minus 1 over 25 times 300, you take the derivative of 1 over 25 times 300, you get 0. That's just a constant. Derivative of 1 over 25 times W is 1 over 25. But we don't know the derivative of W because we're dealing in terms of T, so we're going to do dW over dt again, just like we do with implicit differentiation. All right, so now we know what dW over dt is. So dW over dt was what they gave us first in the beginning. So this is 1 over 25 times 1 over 25 times W minus 300. And that's our second derivative. And again, if you want to simplify or don't want to simplify, you can make that 1 over 625, w minus 300. All right, well, they want us to figure out if this is an underestimate or an overestimate using the second derivative. Remember, second derivatives tell us about concavity. So if I go ahead and figure out, all right, this wants to know at t equals 1/4, okay? Well, if I figure out at 0, okay, at t equals 0, w is 1400. Well, if I put that in, for w, I get a positive number. I should put t equals 0 here. This is a positive number. This is going to be greater than 0. Well, since that's greater than 0, we know that it's concave up. So w is concave up. Well, let's think about what that would look like. Here's a tangent line. And here's the point at 0. If your graph is concave up at that point, and let's say this is your approximation we found in part A, what does that tell me about the actual value? All right, that approximation from the tangent line is going to be less than the actual, so it is an underestimate. All right, we can see that the tangent line would be under a curve that's concave up. If it was concave down, then we'd have the other situation happen. It would be an overestimate. But in this case, it's underneath the curve. All right, let's go on to C. Find the particular solution, w equals w of t, to the differential equation that we are given with the initial condition. All right, differential equations are huge. This is major points that you can get for your FRQ. All right, and it all comes down to solving a differential equation. So let's start off with dw over dt equals 1 over 25 w minus 300. All right, whenever we have a differential equation that we have to solve, we're going to separate and then integrate. You get points for almost every piece of this. So when you separate, you get points. So we're going to divide by w minus 300, and we're going to multiply by multiply by dt. Right there, that's a point. Then you're going to integrate. Sometimes you get a point for both integrals, sometimes you get one just in general for doing both integrals. Sometimes you get them for each. So when I integrate this, this is natural log w minus 300. This is just going to be 1 over 25t plus c. All right, remember that when we got to get rid of natural log, we e it, which gives us 1 minus 300 equals, remember whenever we have that plus c up there, it becomes ce to the 1 over 25t. And then I like to solve for w first before I do anything else. So I got plus 300 here. Last thing I have to do before I get any further, plus c, that's a point. All right, solve for w, that's usually a point. And the last thing is we got to actually find out what c is to finish it off. And that's where we use our initial condition. When you use that initial condition, that's also a point. So I'm going to take 1400, I'm going to put it in and put 0 in for t. And we end up with 1400 equals c plus 300. So c must be 1100. And don't stop there, put it back into your w equation. So w of t, and you could just write w, but w of t is a little nicer looking. 1100 e to the 1 over 25t plus 300. And that would be our particular solution for this, which is the last part of this question.